In this solution series, I am solving important questions on general topology from previous year NSOU PG exams. And our next question says, let X is equal to R and T contains the empty set and complement of all finite subsets of R. Is T a topological space? We have already discussed about cofinite topology in my first video. Okay, now we have to prove that this forms cofinite topology. The first given condition is phi belongs to T or tau, whatever. Phi belongs to tau. And since complement of X in X is phi, which is a finite set, this proves that X also belongs to tau. Right, X also belongs to tau. Now we have to show that any union of any number of elements of tau is also belongs to tau. Now let us take a family A alpha, where alpha belongs to lambda, containing the elements of tau. We have to show that union of these A alphas belongs to tau, and to show that we have to prove that complement of this set is a finite set. Okay, only then we can prove that this union belongs to tau. Since this is a set containing elements from tau, so complement of each A alpha is finite. Okay, so now X minus union of A alphas. By De Morgan's law, we know that this is equal to intersection of X minus A alphas. And since this is a subset of X minus A alpha for some particular alpha, okay, and since each X minus A alpha is finite, so this is finite, and this being a subset of X minus A alpha, this intersection is also finite. That means this set is finite, which implies that that union of A alpha belongs to lambda, belongs to tau. Now we also have to prove that intersection of a finite number of elements of tau also belongs to tau. Again, let B alpha, where alpha belongs to lambda naught, where lambda naught is a finite set, is a family containing elements from tau. That means X minus B alpha is finite. Since B alpha is an element of tau, so X minus B alpha is finite. We have to show that the intersection of B alpha, where alpha belongs to lambda naught, is finite. To prove that, we have to show that the complement of this intersection is finite. So to prove that, let us take X minus intersection B alpha. Again, by De Morgan's law, it will become X minus B alpha. Okay, now this is a finite set. So union of finite number of sets containing finite number of elements, each containing finite number of elements, is again finite. That means X minus this intersection is finite. So intersection this belongs to tau. Okay, now these conditions together prove that X tau is a topology. Our next question says, for any set A in a topological space Xt, prove that A double barred is equal to A barred, where A barred implies derived set. Okay, now we know that for any set P, it is a subset of P barred by the definition of P barred, since P barred is equal to P union PD. Okay, so A bar, A is a subset of A bar as well, which proves that A bar is a subset of A double bar. Okay. Now conversely, let X belongs to A double bar. Okay, which is equal to A bar union A bar D, derived set of A bar. If X belongs to A bar, then our proof is complete. But if X belongs to A bar D, then X is the limit point of A bar. So for any neighborhood Nx of X, we will have Nx minus X singleton X intersection A bar is not equal to phi. Right. And I am denoting this Nx minus X, this deleted neighborhood of X, as Nx dashed and writing it as A union derived set of A is not equal to phi, which means Nx dashed intersection A union Nx dashed intersection AD not equal to phi. So either this not equal to phi or this not equal to phi. If Nx dashed intersection A not equal to phi, then we will have what? X is the limit point of D, A. So X belongs to AD. That means X belongs to A bar. And if Nx dashed intersection AD is not equal to phi, then there exists at least one U which belongs to Nx dashed intersection AD. Since U belongs to Nx dashed is a neighborhood of U also. Okay. And since U also belongs to AD, that means U is a limit point of A also. That means U is in the limit point of A as well as Nx dashed is a neighborhood of U. So Nx dashed intersection A is not equal to phi. Right. It means that X is the limit point of A. Since Nx dashed was the deleted neighborhood of X, and Nx dashed intersection A is not equal to phi, so X belongs to derived set of A. X is the limit point. In either case, the first one says X belongs to A bar, and the second one also implies that X belongs to A bar. So in either case, X belongs to A bar. Hence, A double bar is a subset of A bar. And from 1 and 2, we will conclude that A double bar is equal to A bar. Right. Next question. For any set A in a topological space, prove that A bar whole complement is equal to interior of A complement. So now let X belongs to A bar whole complement. That means X does not belong to A bar, which is equal to A union AD. Okay, so X does not belong to A and X does not belong to AD, derived set of A. So there must exist some neighborhood Nx of X such that Nx intersection A is equal to phi. Okay, since X does not belong to A and the deleted neighborhood of X contains no element of A, so Nx intersection A is equal to phi. This shows that Nx is entirely contained in A complement, right, and X belongs to Nx, which is entirely contained in A complement. That means x belongs to interior of A complement. Now conversely, let this one proves that A bar whole complement is a subset of interior of A complement. Conversely, let y belongs to interior of A complement. That means what? There exists some neighborhood ny of y such that y belongs to ny, which is entirely contained in A complement. Right? Then ny intersection A is equal to 5. Then there exists at least one neighborhood ny of y such that which does not contain any point of A. That means y does not belong to A bar, right? Then y belongs to where? A bar whole complement. Therefore, interior of A complement is a subset of A bar whole complement. So from both of the equations, we get A bar whole complement is equal to interior of A complement. Proved. The next part of this question is quite similar, so I am leaving it to you. So that is it for today, and don't forget to like, share and subscribe. Thank you.